Today we're going to take a look at solving formulas for different variables. This is going to look a little different than the equations we've been solving because you're going to have several variables in a single equation. But the process for doing these is exactly the same as solving equations, so you want to keep that in mind the whole time. If we look at this first example, we can see that they are asking us to solve this equation for x. So x is over here. I'm going to go ahead and mark around that x just to help me keep in mind what I'm solving for. Remember, when we're solving, we're working basically in reverse order of operations. So I want to disconnect anything held on by addition or subtraction first. So I want to move this 7 here. So I'm going to do that by doing the opposite. So I'm going to subtract 7 from both sides. Now, when I subtract 7 on the left-hand side with the y, those are not like terms. So they are not going to combine together. These 7s do cancel out. But then over here on the left-hand side, I'm just going to have y minus 7 equals, and on the right-hand side, I am left with 5x. So my goal still is to get the x on the right-hand side by itself. So I want to get that x all by itself. So I have to get rid of the 5. To get rid of the 5, I need to divide. So when I divide by 5 over here, that's going to cancel the 5 out. When I divide over here, I have to make sure that I divide the entire side by 5. So these 5s on the right-hand side are going to cancel out. On the left-hand side, I can separate these into two fractions. So I can rewrite this as y over 5 minus 7 over 5. But you will notice that neither of those are going to reduce. So we're just going to leave it like that. And this is equal to x. So that's our solution on this first one. As I move to the next one, you will see again that we are being asked to solve for x. So my x is over here on the right-hand side. Here's my wall through my equal sign. So the first thing I need to get rid of is anything held on by addition or subtraction. So I'm going to get rid of this 8 by adding 8 to both sides. When I go to add 8 to the left-hand side, this negative 4 that's already here is a like term. So I'm going to align that 8 under the negative 4. So the 8's on the right-hand side are going to cancel each other out, which was our goal. Goodness. So that was our goal, to make those cancel out. So we will see those cancel. On the left-hand side, I have y. Negative 4 plus 8 is going to give me positive 4. So, and this is equal to, the only thing I have remaining over here is 3x. So now, to get x by itself, I need to divide both sides by 3. Remember that when you divide over here, you have to make sure you divide the whole entire side, meaning that that 3 is going to apply to both the y and the 4. These 3's will cancel out. So I have y over 3 plus 4 over 3 equals x. So that is our solution. We got x by itself, which is our goal. Moving to our next example, you will see that they're now asking us to solve for z. So my goal in this one is to get this z here by itself. Here's my wall through my equal sign. So I'm looking to get rid of anything on the same side as z. So what I see over here is this 4x that's being held on by addition. Since this is a positive 4x, to get rid of it, I'm going to subtract 4x. And remember, if I subtract 4x on the right, I also have to subtract 4x on the left. Neither of these are going to be like terms with the 4x because neither of them have an x in them right now. So on the right-hand side, these cancel. And on the left-hand side, I'm just going to have a list of the things that you see here. So we had negative 13 already there, plus y. And now I have also a minus 4x. And that is equal to z. So in one step, I was able to get z by itself. That is our answer. Moving to our next example, notice here that I'm being asked to solve for a. So the a that I'm solving for is in here inside of the parentheses. We know that when we see a set of parentheses with a number written outside of it, that means that we are going to need to distribute. So we are going to go ahead and distribute here because that is going to impact our a. So I'm going to distribute 3 to here and to here. So when I do that, I have 6b minus 3a. And that distribution does not impact the right-hand side at all. So the right-hand side is still going to be just C. So now I'm working to get A by itself. So I look for anything that's held on by addition or subtraction. So that would be this 6b. And since 6b is positive, to get rid of it, I'm going to subtract it. So I'm going to subtract 6b from both sides. Now when I subtract that on the left hand or on the right hand side, 6b and c are not like terms. So they are not going to combine. They both will be just listed on the right hand side. So at this point, I have negative 3a equals c minus 6b. And now I need to get rid of this negative 3. So to do that, I'm going to divide both sides by negative 3. And remember, when I divide on the right-hand side, that means that both the c and the 6b are getting divided by negative 3. So these cancel out. So I can say that A equals C over negative 3. And then a negative divided by a negative would give us a positive. So that would be positive 6b over 3. Now, you probably notice here that 6 is divisible by 3. Another thing to notice here is that we have this negative here in the denominator. Typically, we don't write a negative in the denominator. That negative just makes the fraction itself become negative. So I can write that piece as negative c over 3. So basically, I'm just taking that negative out front. 6 divided by 3 would be 2, so I write this as plus 2b. So that is our solution. Moving on. In this one, notice that I'm being asked to solve for p. Here's our p that I'm being asked to solve for. So anything that's held on by addition or subtraction needs to go first. So I see that I have this m over here. The m is positive, so to get rid of it, I'm going to subtract m. So I'm going to subtract m on both sides. So the m's on the left-hand side are going to cancel. So that means that I am left with negative HP equals D and M are not like terms, so they will not combine. So just D minus M. And now I need to get rid of this negative H. These are being squished together, so that means they're being multiplied. So I will get rid of that by dividing. So I'm going to divide both sides by negative H. So the negative H's on the left-hand side are going to cancel out, leaving me with just P. So I can say that P is equal to, so D over negative H, and then a negative M divided by a negative H would give me a positive, so a positive M over H. So you can leave your answer like this. It's not going to reduce. If you wanted to put this negative here out in front and just make the whole fraction negative, that would be fine, but this is an acceptable answer. Moving to this one, we can see that we have fractions on both sides. You guys actually saw something like this in middle school, and when you were solving something like this called a proportion, you learned to do that by cross multiplying. So by cross multiplying here, we are going to get ourselves to a point that we are working with something that does not involve fractions, which is going to make this a bit easier for us. So when I cross multiply this direction, I get AB times F. So I'm just going to write that as ABF. And that's going to be equal to what I get on the other diagonal, C times D. So I'll just write that as CD. Now my goal is to get B by itself. So if we focus on that B on the left-hand side, you will notice that you also have A and F with it. Both the A and the F are being held on by multiplication. So the opposite of multiplication is division. So I am going to divide both sides by AF to get rid of those. So I'm going to divide by AF over here as well. So these A's cancel. Those A's cancel on the left-hand side, and the F's cancel as well. Now over here on the right-hand side, nothing cancels or reduces. So your answer in this case is just B equals CD over AF. All right, next example. This one should look familiar to you. This is the formula for area of a triangle. Area equals 1/2 base times height. And my goal here is to make it so that H is by itself in this equation. So here's the wall through my equal sign. And I can see that on the same side as H, I have that 1/2 and the B. We learned when we were solving one-step equations that when we are trying to get rid of a fraction that's being multiplied, we multiply by its reciprocal. The reciprocal of 1 over 2, so I need to flip it over. That would become 2 over 1. So basically I need to multiply both sides by 2. So I'm going to multiply by 2 here and multiply by 2 over here. On the right-hand side, the 1/2 and the 2 are going to cancel each other out. So that means that at this point I have 2A equals BH. So now to continue trying to get H by itself, I need to get rid of that B. The B is being multiplied right now, so to get rid of it, I need to divide by B. And if I divide there by B, I also have to divide over here by B. So these will cancel out, which means that I can say that 2a over b equals h. And that is your solution.